pre-calculus students to class today on Friday the 27th. Hope you guys are doing well. Hope you've had a good week so far, and I hope you're looking forward to having a nice weekend. I was just thinking, I know it's still about 3 weeks away, however, fall break is coming upon us relatively quickly. So when this week is over, we have accomplished 7 weeks, so congratulations. And we're doing 10 weeks for the first quarter and then 8 weeks for the second quarter. So in about 3 more weeks, we will have our fall break. Take a whole week off. So I know you guys are looking forward to that. Let me get this MemoPad working. Hold on 1 second. Slide that down. And let's make some announcements. Here we go. There will be a quiz tomorrow on Saturday. I will email that to you sometime. Saturday morning, Saturday afternoon, Saturday late morning. So be looking for that. Keep your integrity sheets updated. My advice to you is every time you watch a video and then do the homework, you immediately pull out your integrity sheet and you make note how many problems you did. Okay? That's my suggestion to you. Your tests are due by today. Now I've got it written here in my day timer that if I've not heard from you by today, or if you've not brought it by my house, then I'm going to be contacting your parents. Caleb, you turned yours in, so you're good there, and you did really well on your test, so congratulations to you. And so be sure and get those tests in, guys, okay? That's really, really important. Now, let's go over the quiz. You're going to have a quiz tomorrow, so why don't you quickly write down, or you can go back later and re-watch this part of the video. But here's what's going to be on your quiz. It's really not that long. First of all, the sine and cosine graphs. I'm not sure how many of these I'll give you, probably one of each. And you'll have to know how to find the vertical shift and the horizontal shift and the period, and take the period and divide it by 4, and the amplitude, and so on and so forth. Okay, so make sure you know how to graph the sine and cosine graphs before you take the quiz. Airplane word problems. I didn't think those were too difficult. Just simply remember. And for some reason my computer's freezing up, so if this continues, we'll have to pause the video and try to fix it. All that you have to remember, of course, is when dealing with airplanes, you always start here on the positive y-axis and you rotate around clockwise. Okay? That's all you need to remember there. And then, of course, solving the airplane word problems. And then the arc, the central angle problems, where theta, the measure of the central angle, equals S, which is your arc length, over R, which is your radius. So any of those problems there that we did from yesterday are fair game. And then lastly, today's stuff. And I just kind of put stuff in parentheses. Any of the problems on today's homework are definitely fair game for your quiz. Please study. Make sure you're really prepared for your quiz before you take your quiz. Now, without any further ado, let's go ahead and get started with your notes today. So please grab your books, your calculators. Make sure you have your brains with you. Have your pen, pencil, notebook, and let's take some notes. We're going to start getting into a bunch of trig identities. And if you're wondering what those are, there's stuff like this, that, and that, okay? And so we're going to start getting into trig identities. So your heading today is, and there's all kinds of different trig identities, okay? We're going to get into basic trig identities today, the basic ones, and we're going to learn some identities today that are called the Pythagorean identities, okay? The lesson today is 6.1 if you're one that likes to keep track of the date, which I encourage you to do. Today is the 27th of September, okay? Basic trig identities and Pythagorean identities, lesson 6.1, today's the 27th. Now, we are going to start learning some trig identities. You don't need to memorize them, but you do need to have a trig identity sheet and be familiar with them, or with these trig identities. Let me say that again. I'm not going to expect you to memorize these, but you do need to have a trig identity sheet and be familiar with them. When you take your tests and your quizzes from now on, oh, and by the way, let me back up. On your quiz here, you're welcome to have beside you the 7 steps. Now, you're only allowed to do this when I tell you. Okay, don't just assume, Oh, with every quiz we can have our notes out. No, 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 no. But on this quiz, you are allowed to you are allowed to have out your 7 steps for graphing sine and cosine graphs, but that's it. No explanations on how to do the 7 steps, no examples to look at, just the 7 typed steps or 7 written steps from your notes. Also, today's stuff right here, you're welcome to have these trig identities here written on a sheet of paper, and you're also welcome to have these trig identities here written on a sheet of paper before you take your quiz. In fact, that leads me up to what I'm saying now. Men, would you please listen to me? You need to start an official trig identity sheet. And this is going to be a sheet of paper in which every time I introduce a new set of trig identities, you pull this sheet of paper out and you write them on there. You don't write them in your notes, you write them on the trig identity sheet. And the reason is I want you to have, anytime we take a test or a quiz, I want you to be able to pull out a trig identity sheet with all your trig identities on there, and you can use them for your tests and quizzes, okay? So you may as well get ready to do that now, because in a second I'm going to introduce some trig identities to you. So you may as well get that blank sheet of paper and label it real big across the top, official trig identity sheet, and then you're going to start writing all of these things down. Let's go ahead and take a look at our first set of trig identities. Here are the basic trig identities. If you would like to turn your book, you will find them on page 534. Now for your trig identity sheet, you might want to take your book, photocopy this page somewhere, and then cut out this sheet here and glue it on your paper instead of writing them all. I don't care how you do your trig identity sheet, but be sharp with it, be professional, and have it with you at all times when it comes to your math class. Okay, sine of x equals 1 over cosecant x. Cosine of x equals 1 over secant x. Tangent x equals 1 over cotangent x. By the way, tangent equals something else. Tangent equals sine over cosine. Pretty cool. Cotangent equals cosine over sine. Cosecant equals 1 over sine, secant equals 1 over cosine, cotangent equals 1 over tangent. Now these you already knew. I taught you from day one that sine and cosecant are inverses. I taught you from day one cosine and secant are inverses. I taught you from day one tangent and cotangent are inverses of each other. So those you should have known already. Look at this. When you take sine of a negative angle, sine negative x, in other words, if I had sine of negative 30 degrees, look what it says. That's the same thing as putting the negative sign out front, and then your x becomes positive. So negative sine 30 degrees. Just different stuff like that that you have to look at here and memorize, or not memorize, but be familiar with. So sine of negative x equals negative sine x, cosine of negative x. In other words, cosine of a negative angle gives you cosine of x. Tangent of a negative angle gives you negative tangent of x. So these are trig identities you really need to be familiar with, and they need to be entered on your official trig identity sheet piece of paper. Let's go ahead and move on to go ahead and label these on your trig identity sheet the Pythagorean identities. You'll find these on page 535. Now, being the math geek or the math nerd that I am, I would love to get into teaching you where these came from. Now, if you want to see an explanation of why they're called the Pythagorean identities, that explanation starts on page 534, and I'm sure you guys are just dying to read all about that. But if you want to, that's where you'll find that. And for the sake of time, I'm not going to get into the deeper reasons why. But you need to be familiar with these trig identities. Sine squared of x plus cosine squared of x equals 1. 1 plus cotangent squared of x equals cosecant squared x. And 1 plus tangent squared x equals secant squared x. Now, I would like to say to you very quickly, excuse me for yawning, when you see sine squared x or cotangent squared x or any of these trig identities that are squared, it does not mean this. When you see sine squared of 30, that does not mean the sine of 900 degrees. In other words, 30 times 30. When you see sine squared of 30, that just simply means you're taking the sine of 30 And my computer's freezing up. Sorry about that. And the sine of 30 twice. So the sine of 30 times the sine of 30. That's what sine squared 30 means. Just so you know, we're not going to need to know that right now, but something to be familiar with. So here are the Pythagorean identities. Okay? Now I'm going to start throwing stuff at you. It's going to seem weird. It's going to seem scary. It's going to seem difficult. But I'm going to tell you right now, if you'll take really good notes, do your homework really, really well, check your homework when you're done, the odds in the back of the book, and check the evens with the video, and then the ones that you miss, go back and watch the video and get help on those. If you do that, you will be okay with this math, but you're going to have to work hard. Now, we're going to go ahead and start using these trig identities here and these here, and we're going to start doing some manipulations with some math problems. So here we go. I'd like you to write down your notes. Let's take a look. Well, you don't have to write, let's take a look, but write down multiplication and simplifying. So we're now going to start taking some of these problems here, and we're going to do multiplication and then simplify. Now, here's what I'd like you to do. Please listen to me carefully. When you're given problems that say multiply and then simplify, it's really hard to know after you do your multiplication how far they want you to go with the simplifying. So what I'm giving you permission to do is to look in the back of the book first and get your answer, and then you'll know how far they want you to go. I have no problem with that. So that's the answer right there that we're supposed to get out. So let's see what happens. Are you ready? I want to take this trig expression, I want to do the multiplication and then simplify. So I have cosine times tangent and then cosine times secant. We should know how to do that. So cosine x tangent x. Okay, that's easy. Cosine times tangent is cosine tangent. And then cosine times secant, well, it's a positive times a negative, so we have a negative. And cosine times secant is cosine. And again, that's not bad handwriting. My computer's really freezing up here. I'm not sure exactly why. There we go. Cosine x, secant x. Now, you did your multiplication correctly. Cosine times tangent, cosine tangent, cosine times secant, cosine secant. But now we're supposed to simplify and get this huge mess right here to look like this. Now that's not going to be easy, so let's see if we can figure this out, okay? Now first of all, if you'll look at your basic, you should have your notes out or your book out to page 534 and 535. If you look at your basic identities, cosine here, I'm trying to think this through, would be the same thing as, well, I'm not going to do anything. I'm just going to say cosine over 1. That's okay. I can put anything over 1. Now guess what I'm going to put for tangent? If you'll look at your trig identity sheet, you're going to see tangent is the same thing as sine x over cosine x. Okay? So I can make that substitution. So for tangent x, I substituted sine over cosine. Okay? Now let's come down here. Why'd you do that, Mr. I'll show you why in a second. Just watch, okay? Now, cosine. Now think about this. Cosine is the exact same thing as cosine over 1. And secant, if you'll look at your basic trig identities, secant is the same thing as 1 over cosine. Now, if I can read your minds correctly, you're probably thinking, Mr. Earhart, once you write it down, I understand why you did it, but I would have never thought to have done that on my own. And that's just where I say experience, experience, experience. And that's why if you'll look back a couple pages in your notes, I said, be familiar with these trig identities. And the only way you're going to be familiar is to practice. I'm not asking you to memorize them, but be familiar. All right? Well, Mr. Earhart, why'd you do all of this substitution? Well, here's why. Cosine over 1 times sine over cosine. Your cosine here would cancel with your cosine here. 1 times sine is sine, and 1 times 1 is 1. So we have sine over 1, which is just sine. And then bring down your minus sign. Now look at this. Cosine over 1 times 1 over cosine. Your cosines would cancel. So 1 times 1 is 1. 1 times 1 is 1. 1 over 1 is 1. And as I like to say, booyah, look at that. We did it. So we did our multiplication first, and then we did our simplifying. Okay, and again, you're going to have to practice this. I'm not being mean, but you're probably not going to be good at this at first. It will take practice. All right, let's try the next problem. All right, go ahead and copy this in your notes. We're going to do multiplication and then simplify. Let's go ahead and take a look at the answer so we know how far we have to take this thing. All right, that's what we want to get in the end. All right, let's see what happens. Is that the one I just did, by the way? It's not, is it? I hope not. Let's go back a problem and see. No, it is not. Okay, good. All right, here we go. Tangent times cosine would be tangent x cosine x. And then tangent times cosecant would be negative tangent x cosecant x. Now maybe you'll want to pause the video. It's up to you. And try this on your own. Or you can keep watching the video. That's up to you. I'm just trying to help you get a little experience here with what we're doing. Did not mean to do that. And let's do that and continue on. Now, again, for tangent right here, I'm going to go ahead and put sine over cosine. And the reason I'm doing that is I realize right over here I have cosine. And if I put sine over cosine for tangent, look what happens to your cosines. In just a second they're going to cancel out. So that's why I did that. Now over here, let's be careful. Over here, I want to get a secant. Now the only way I can do this, I'm trying to think here. I think what I'm going to do is for tangent, I'm going to put sine over cosine. I think that's what I'm going to do. And then notice if I bring down cosecant, that's not going to cancel with anything. Maybe for cosecant, if you'll look at your basic trig sheet, cosecant is the same thing as 1 over sine. Do you see that? Look here at the screen if you're not seeing that. Right here. Cosecant is the same thing as 1 over sine x. Right there. All right? So, I'm going to go ahead and put that in place of cosecant, so my sines will cancel. Again, you're kind of new at this, but you'll figure these out as we go along. Well, sine over cosine times cosine over 1, your cosines cancel. Sine times 1 is sine, 1 times 1 is 1, so we're left with sine x minus, and then over here, your sine cancels with your sine, so 1 times 1 is 1, and cosine times 1 is cosine x. Oh, we failed. We didn't do it. We wanted to have sine minus secant x, but hold it. See this secant x right here? See that? Go back to your Trig Identities page. What does secant x equal? 1 over cosine x. Do you see it right here? So for 1 over cosine x, I can now put secant x. So minus secant x, because 1 over cosine x equals secant x. So I make a substitution, and there we go again. 2 for 2. Let's try one more, then we'll look at some 3 other problems for another type. We're going to do another type of problem 3 different times, and then we'll be finished for the class period. Okay, now let's go ahead and do what we've been doing, some multiplication and then simplifying. So let's take a look at what the answer should look like. That's the answer we should get, and let's see how we do. 1 plus tangent squared would be 1 plus tangent 1 plus tangent. We should know that. Now here we go. Take your 1, multiply it times 1, multiply it times your tangent. Okay? So 1 times 1 is 1, and 1 times tangent would be tangent x. Okay, very good. Now take your tangent x, multiply it by 1, and multiply it by tangent. So let's see what happens. Tangent x times 1 would be tangent x. Anything times 1 is itself. And tangent times tangent would be, now watch how I write this, it's tangent squared x. There we go. Now, be very careful here. I have a tangent x and a tangent x. We call those like terms. There's a 1 in front of this one and a 1 in front of this one. So you're learning something new here. So I really have 1 plus 2 tangent x plus tangent squared x. Now, here's the answer they want us to have. I want to have in my answer 2 tangent x. So I definitely want to keep this. But somehow I don't want this 1 and this tangent squared. Hey, I just had a thought, and I don't have many of those. Let's go back to our Trig Pythagorean page here. Hey, look at this. 1 plus tangent squared equals secant squared. 1 plus tangent squared equals secant squared. So, hey, I can rearrange these terms. I can put the 1 first, and then my positive tangent squared second, and then my 2 tangent x third. And now look what we have here. 1 plus tangent squared equals secant squared. So 1 plus tangent squared, I can make a substitution for that, and I can put secant squared. So secant squared x plus 2 tangent x. And one word comes to mind, and you know what that word is, and that's cool. That is so cool. So what we did is we looked at 3 basic problems in which you multiply and then simplify. You know what we're doing? You're putting me to sleep, Mr. Hart. No, what we're doing is we're working on or practicing using your trig identities. It's very, very important. All right, now let's try one other thing, and I'll leave you alone for the day. Let's try to factor, yes, factor some trig expressions, and after you're done factoring, simplify. All right, so let's give that a shot. Go ahead and write down this problem here. And now I'd like to give you a little advice. Remember how the last 3 problems we did, I encouraged you to uncover the answer? Well, don't do that with these. Don't, Mr. Earhart, that's right, don't. First, factor. Because I want to make sure you know how to factor, guys. First, factor. And then when you're done factoring, then uncover the answer, and then you know how much simplifying they want you to do. Okay? So let's factor first. You learned in the first week or 2 of class to always pull out what's common first. Now you should know by now this is one term. That's one term. Now if there's a plus sign right there, then it would be 2 different terms. But because the sine and cosine are multiplying, that's one term. Then here's a plus sign. Then here's another term. So do you see anything common you can pull out? Well, I do. I see how many cosines here? 2. How many cosines here? 4. The most I can pull out would be 2, so I'm going to pull out what's common, so I'm going to pull out cosine squared. Now when I do that, let's see what we're left with inside the parentheses. Cosine squared times something gives me sine squared cosine squared. Well, that would be sine squared. Think about that for a second, guys. Cosine squared times sine squared would be cosine squared sine squared. And then cosine squared times something would give me cosine to the 4th. Well, wouldn't that be cosine squared? Cosine squared times cosine squared gives you cosine to the 4th power. In other words, if you were to take this cosine squared and multiply it back through, you would get what you started with right here. Okay? So have we factored and pulled out what's common? Well, the answer is yes. Yes, we have. Now look what they want you to simplify, and they want you to get that answer right there. Now how in the world are we going to do that? Well, I'm really familiar with these trig identities. I've taught these for so many years, okay? Right away I think of the Pythagorean. Whenever you're seeing some squares like this, think Pythagorean identities. Look at this identity right here, men. Look at this right here. Sine squared plus cosine squared equals 1. Now go back to this page we were on. Look, sine squared plus cosine squared, that equals 1. So now I can put cosine squared x times 1. This whole thing equals 1. How cool is that? So now cosine squared times 1 is just cosine squared x. I did it. I matched it up. All right, let's try another one. Now, look, it's a binomial, right? First of all, pull out what's common. Well, I see nothing common, and hopefully you don't either, or I'm going to kind of question your vision there. There's nothing common. But I have a question for you. I have a tangent squared and a cotangent squared. Look, students, if I had an x squared minus a y squared, remember when you know the square root of both terms, you take the square root of x squared into the square root of y squared, and then make one positive, make one negative. I hope you remember that. That's called factoring the difference. Oops. That's called factoring the difference of 2 squares. Well, we do the same thing here. Just your parentheses will be a little bigger because you have bigger words to write, but What's the square root? Do we know the square root of both of these terms? Yes, we do. What's the square root of tangent squared? Tangent. So I'm going to write tangent here and tangent here. What's the square root of cotangent squared? Well, cotangent, so I put cotangent here and cotangent here, and then make one positive and make one negative. Now let's unveil the answer and let's see how far they wanted us to simplify. Well, look at that. They didn't want us to do any more simplifying. We're done. And do you see now why I did not want you to look at the answer first? Because if you would have looked at this answer, then you would have known how to do what? Factor. And I don't want you to know how to factor by looking at an answer. I want you to know how to factor because you know how to factor. So factor first, and then look at the answer over here, and we're good. There's no simplifying to do. So one more problem, and we're finally done. So good job listening today, and we're just about finished. Wow, this one's going to be a lot of fun. Yes, I'm being sarcastic. All right, 4 sine squared plus 8 sine plus 4. Now, I would like to show you a really cool shortcut if you will let me. I have a sine and a sine, and they're both sine of y, sine of y. Do you see that? One's squared and one is not. Since they're both sine of y and one is squared, why don't you rewrite the problem like this? Now just watch. Instead of putting sine squared y, I guess I should have used the y, shouldn't I? I'm sorry about that. There. Instead of putting sine squared of y, just put y squared. And instead of putting sine of y, just put y. Notice there's a 4 out front, so I put a 4 here. Notice there's an 8 here, so I put an 8y. Mr. Earhart, you can't do that. Well, you're right. I really can't. Unless, at the very end when I'm all done factoring, then I put my signs back into my final answer. Well, Mr. Earhart, why would you suggest that? Look how weird this looks when it comes to factoring, but look how normal this looks. We have factored trinomials like this over and over and over. In fact, I'm going to prove it to you right now. Let's factor this. What's step 1? Pull out what's common. Does every term have a y? No, not at all. However, I can pull out a 4. That's the largest number that goes into 4 and 8 and 4. So factor out a 4, and you're left with y squared plus 2y plus 2. Excuse me, plus 1. 4 times y squared, 4y squared, 4 times 2y, 8y, 4 times 1 is 4. And now look what you're left over with. You're left over with a trinomial that has a lead coefficient of 1. Those are the easy ones to factor. And so I'm going to grab this 4 right here and just bring it on down to here so I don't have to worry about it. And now let's just factor this trinomial. It's a lead coefficient of 1. So do you remember what to do? We say to ourselves, what two numbers when multiplied together give me this number, but when added together give me this number? Well, that's not too hard to figure out. How about a positive 1 and a positive 1? I mean, 1 times 1 is 1, and 1 plus 1 is 2. So for the factorization, I'm going to have y plus 1, y plus 1. And then don't forget you should have a 4 on the outside. So we're going to grab this and drag it down here. And there we go. We factored it. Almost. Now don't forget we got to go back and put the word sine in here. So here's your final factorization. Are you ready? 4 parentheses. See this y right here? I'm going to put sine of y plus 1. And then see this y right here? I'm going to put sine of y plus 1. Now to me that was easier to factor this than trying to factor this over here, but you do what's easiest for you, okay? Now hold it. We might be done, we might not be. Let's see if they want us to do anything else. Look at that, they don't. So we did not have to do any more simplify. I guess I typed an x here and I should have typed a y, so I apologize. Make that a y and make that a y. There we go. So students, there is no simplifying to do, so that's it. Now, as you start your homework, I want to show you something that's really important, so I hope you will listen to me. I'm turning over very quickly, if you'll just wait for a second, to page 544. Now, listen to me carefully, and I will explain this well. Numbers 1, 3, 4, and 5, and 7, those are the ones where you multiply and then simplify. So on those, you're more than welcome to turn to the back of the book and look at the answer first right away, and then start working the problem out. But for numbers 9 through 16, 9, 11, 13, 14, 15, 16, those problems here, for these problems here, those are the ones where you factor first and then simplify. So please don't look at the answer in the back of the book until you first do what on your own? Yeah, you guessed it, factor. And then when you're done factoring, then turn to the back of the book and look at the answer, and then take that problem and see if you can simplify it a little further, okay? I hope this has been an easy video to understand. Please work hard, do the homework, check your answers, call me or email if you have any questions.